Yeah, today let's show you how to do regressions by using example. So let me show you an example, which is the simplest one, which is a simple regression example. Let's say our research question is asking whether house prices will be associated with economic growth. The equation is delta PT, right? The house price year-on-year change is related to a constant term alpha, also the year-on-year change of the GDP, and the estimated coefficient is beta. So it can be interpreted as a kind of correlation analysis between two variables in this simple regression example. And the time series chart is shown here, right? The blue line refers to the year-on-year change of the GDP, and the orange line refers to the year-on-year change of the house price index. So if you plot this time series in terms of a scatter plot, and you will find a very clear positive relationship, except the recent negative growth in GDP during the pandemic. So most of the relationship are in this positive relationship, and that's why the best fit line would be the orange line here. And then how can we estimate by using regression? The result is shown here. And you find that, right, the coefficient is a positive 1.57 with a highly significant p-value. And the interpretation is that 1% increase in the GDP year-on-year change is associated with 1.57% increase in house prices in upland. Of course, this is for demonstration purpose. So we just include one variables and a constant term, well, which may not be good enough, but at least it demonstrates how to run the regression. Let me show you, right, in Excel. Reserve Bank of New Zealand provide both house price index data series in quarterly series. Here shows the data series of house price index from 1991 to 2021. And then it also provides the GDP time series, as well as the year-on-year change in nominal term and in real term. So combining these two, here shows you the data series, the house price index. I just extract 2001 to 2021, then the year-on-year change of this house price index, and also the GDP year-on-year change. So here, right, you will find that the two year-on-year change is positively correlated in about 54% correlation coefficient. And then let me show you how to estimate this regression result. So as I mentioned, if you click data, and if there is a data analysis function here, then you can directly click this data analysis command, and then scroll down. There's a regression function. Click OK. Then it asks you to input the Y range. Now, because we assume that GDP growth would affect house price growth, so the dependent variable is the house price. And if we select column C, where the house price year-on-year change as the dependent variable Y, then the X variable would be the GDP year-on-year change. Okay, after selecting these two, and because I did not include the label, so I leave blank. And if I select to output the result, you can also include those diagrams of the residuals, right? Let's say, for example, I only include a line feed plot. Click OK. Yeah, so that's exactly the same, right, as I have done before. So the interpretation is here the R square, referring to the explanatory power, is about 29%. And the X variable, right, is the GDP YOY, and the dependent variable is the house price index year-on-year change. And so, right, the interpretation is 1% growth in GDP will be associated with 1.57% increase in house price index. And this is the chart showing the relationship, right, the scatter plot between the two variables. In case, right, if your system, when you click data, does not provide data analysis, then you have to click File, Options, Add in, VBA, Go, then click the 2-pack and 2-pack VBA, click OK. Then it will, right, provide this data analysis. That's all. Thank you.